Hello everyone, how are you guys doing? Hope you guys doing well. It has been a while since I streamed. Has been a couple of days, and I did say I want to stream more often, but I I'm going to try and stream 3 lectures today. So 1.5 an hour, 1.5 an hour, 1.5 hour. No promises, but I'll try to stream a lot today because I really need to catch up on this game. And one of my Discord uh, members who joined the server asked for to do UI stuff, and UI stuff are really exciting. I love doing UI stuff, or creating a UI framework. So I'm really kind of excited to do that today. But before I jump into that, I really want to finish kind of this, right? Now, what I usually like to do, I usually like to kind of at the beginning of the stream, to kind of talk about things that are happening in my life and kind of, what things I've been learning and, just general chat, half an hour chat, 40-minute chat, something like that. But I feel like the topic I want to talk about today is kind of, or the chat that I want to do today is more of a rant on the state of software. And so I might just do a full stream for that. I really don't want to and I think people usually expect when they come to the stream, just get into the topic, just teach something, right? So I might just do different live streams where I just rant for 30 minutes, 40 minutes, things like that. But yeah, we'll see. Anyway, so I just want to jump to this and get going. So last time, if I remember correctly, we had a tile, and I can click anywhere, and that position is being shown on the screen, right? And that was kind of the whole objective. Is if I click anywhere on the screen, it'll give me the coordinates of that single grid point tile thing, and I'm supposed to add a tile in that location, right? And so I kind of want to do that. So I'll do that. If I remember correctly, we had the mouse tile class, which has a function. We created a function that was like, hey, if you press the mouse button, then update the tile position, and it'll give us the tile position. And inside the map class, we go ahead and just print that tile position, right? So now I can do this really easily, and I'll do it fast, and then I want to jump to UI because again, UI is something really exciting. Hello, Anmar. Welcome to the stream. I keep hearing in my head saying scream. I mean stream, but Anyways, so I kind of want to jump to this real quick. So what I want to do is just create a vector, right? I'm going to create an std vector. Vector of type sprite, SF sprite. We're going to have a bunch of sprites. A bunch of sprites. I'm gonna call them, I don't know, map, something like that. It's not happy. Why are you not happy? Oh, sprite, capitalist sprite. Okay. And so, should I make a vector? There's no reason to add a vector. So I'm thinking in my head, I'm like, okay, I can either make a vector and then add stuff to that vector. All right, and we talked about this previously. We said that, hey, hey Kareem, welcome to the stream. And we kind of talked about this before in a previous lecture where we said a vector is not super great because there's an issue where you add an element to the vector, and then you add 4 more elements, and then if you want to add the 5th element, it has to relocate all that data to a new memory location, and then you add 5 more elements, and then that data will need to be copied to a new location memory, and so on and so forth, right? Which is not great. Talked about all that in detail before. And so But you can optimize this and just say, hey, this vector already holds 100 elements, so you can allocate that memory immediately. But since I already know the size of my grid, I really don't need a vector. I can just make an array. And I think that's what I'm going to do. I'm just going to make an array rather than a vector. I think a vector is kind of too much. So I'll make an array, SF sprite, and I'm going to call this, it's going to be a pointer to a, what is mmap sprites? I already made that. Oh, this is it. I already made it. Okay, never mind. What am I doing? I completely forgot that I made this. I mean, it's been a while since I looked at this code. All right, so I made this, and I'm rendering everything to it. I just need to initialize it. Okay, I just need to initialize it. Okay. All right, and mouse tile holds the. So mouse tile holds the. What does it hold? What does mouse tile hold? Wait, why do I have a bunch of oh, this is just a comment. Okay. It holds the tile with the position. It holds the texture, and it holds the location in the tile sheet, right? The lookup table. All right, so I need that information in order for me to add something. So what I can essentially do here. Okay, so this is cool, right? I know the location. Okay, so here's the thing. I know the location. If I click anywhere on the grid, I already know that location in pixels. But I also need to know that location in index numbers and indices. Because if I click here, this should be index 0. If I click here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So I need to know where to place this tile, not only on the screen, but to also know where to place it in the array itself. Right, so if I get my Epic pen, and so imagine, oh dude, okay, so hold on, I might have some technical issues. 1 second. So I remember I got a new Bluetooth module or Bluetooth thingy. And so I don't think anything's synced up anymore. So let me just real quick just. Oh, did it work? No. Okay. Bluetooth. I think I already have. Let's connect it again. Will you be happy and work right away without any issues? Hey, look at that. Cool. All right. So what I want you is this mapped to 2 screens again? Oh no, 1 screen. Okay, good. It remembers. All right, so what I want you to imagine in memory, this is literally what is happening in memory, right? So you have your memory, right? And your memory looks like this. This is element 0, element 1, index 3, 4, 5, 6, 7, 8, 9. This is 10, 11, 12. I'm not going to remember all of them, right? And so on and so forth, right? So not only do I need to place this tile on the screen, at, for example, this location. Where's this location? It's 200, 150, right? So this location is 200, 150 pixels. So not only do I need to know this location, but I also need to place this tile in the array itself at index 0, right? Because every frame I need to render index 0 at this location, right? So I need to do both. So right now, the problem is, right now, I only have the location on screen. I don't have the location in RAM. Location in the array. So I need to do that. I hope after all this work creating ECA system with the tiles or anything like that, you know, understand simple. Right, so yeah, so the way I'm architecting this right now is not great, right? As you can see, if I go to the map class, main class. In the main class, right, I have a bunch of classes that call other classes and they reference each other. That is not great, and I will show why that is not great, but I just want to because this is the most straightforward way of doing things, and that's how I kind of did things at the very beginning, and it kind of made sense for me at the beginning of my career, my programming career. But later on, I'm going to show why this is a bad idea and transition to a system later on, right? But I don't want to transition to the system from the start or from the beginning, because I want to explain why this is not super great. This is not the greatest way of doing things. So yes, we're going to create an entity component system at some point, game objects and components, and we'll create also an ECS system later on, right? But for now, we'll do this for now. Anyways, going back to the issue that I had, is this function needs to not only return the tile position, but also needs to return the location, the index number in the array, right? So the way I do that, I can either do it here, or I can calculate it here, right? Either or would work, but I think it would make sense to calculate it here. So I already have data about the grid. So I need the grid position, right? I need this essentially. I need to pass the tile position and the grid position, both of these, not just one of them. Just want to verify that I just want to print this out. I think this is the correct one. So what I'm going to do here, tile position, and I'm also going to do SF vector 2f ampersand grid position, right? So I'm going to put this on multiple lines because now it's just a little bit too long. And now this has 3 parameters rather than 2. So let's do, okay. We'll just do that. Put this paste here. Tile position. This is the tile position. This is the return. I need to fill the mass position and the grid position later on. Okay. All right, so copy all this. I hope this is all making sense, by the way, guys. If anything doesn't make sense, please do ask it in the chat or in the comments. I'll more than happy to explain it. Do I do it like this? Yeah, I think this is nicer. All right, so now I need to return the grid position too. So grid position equal to m underscore tile grid position, right? And both of these are out. So I need to do here tile position. I need to know grid position, tile position like this, grid position like that, tile position, tile position. And then this would be grid position. Not gonna end the new line here. I'm gonna continue this. Space grid position. Blah, blah, blah. This would be grid position, grid position. All right, so this should work in theory. If I click on the first tile, I should get 0, 0, unless this crashes. Grid position is not happy. Equal const. No operator equal matches these operands. Ooh, this is vector to I. Whoops. Okay, so we got okay. So it's really important whenever you're programming, especially as a beginner, to read the error message and kind of understand the error message. So it says no operator equal matches these operands. Operand type are SF vector 2f equal to const SF vector 2i. Essentially what this means is like it's saying, hey, grid tile is a vector 2i, grid position is a vector 2f, and you're making it equal to each other. They're not the same thing, so be aware, right? So I just need to change this to vector 2i. And it change it here to vector 2i. And that hopefully should compile just fine. Nope, still not happy. Oh, this is I. Should be happy now. All right, cool. So if I click here, this should show me 0, 0, which it does, 0, 0. If I click here, it should show me 1, 0, 2, 0, 3, 0, 4, 0, 5, 6, 7, 8, and 9, right? Again, I need to clip this. I need to make sure I don't go to 10, 0, because there is no 10, 0. Otherwise, the application might crash, right? Or most likely crash. So I need to make sure to, this is 0, 1, 1, 1, right? So this is all correct. I have both these data, which are really important to me. I need both of these. So now what I need to do is I can access the array, right, with grid position. Okay, I need to explain this a bit and how I'm gonna do that, or how that's gonna happen. We go here, move this here. Nope, just go down. All right, let's go here. Okay, here's the thing. Right now I have my grid, right? My beautiful grid. Let's do, this is my grid. Okay, this is 0, 0, 1, 0, 2, 0, 3, 0, 0, 1, 1, 1, 2, 1, 3, 1, 0, 2, 1, 2, 2, 2, and 3, 2, right? This is being the x, comma, y. So x is 0, y is 0, right? And the further I go on the right, 1 increments, and then when I go down, y increments, and so on and so forth. Basic stuff. Now here's the issue. Here's the thing. I have two numbers, right? I have 0, 0. However, my array is a single array, right? This is m sprites. So the array takes, it looks something like this. This is how the array looks like. So the array looks like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many do you have? 1, 2, 3, 4. Or sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, exactly 11. Nice. Okay, so I have 11 elements. So when I access the array at index 0, I should go here. When I access the array at index 1, I should go here. Array at index 2, go here. Index 3 would go here, right? Then index 4 should go here. And 5 would go here, 6 would go here, and so on and so forth, right? The problem is I have two numbers. I have two coordinates. I have 0, 0, 1, 0, 2, 0. How do I convert two numbers, a 2D coordinate system, into a one-dimensional coordinate system to access my array? Right? Because essentially what I want to say, I would like to say, hey, at index 2, so m underscore sprites, at index 2, I would like to make this equal to the sprite that I have on the screen. So this would be just the cool sprite I want to draw for my map, right? But I don't have index 2, I have 2, 0. So how can I take this 2, 0 and convert it to a 2, right? Well, it's pretty easy, and there's a rule for that, or there's a small formula for that, which is repeated all the time, essentially. If you want to convert two numbers into one number, that's the rule, or the formula. It's x plus y multiplied by the width of my grid. So how many tiles do I have in my grid? I have 1, 2, 3, and 4. So multiplied by 4. Rather than typing 4, I'm going to say grid underscore width. So that's my formula. So I can take any numbers, any two numbers, and convert it to a single index number using this formula. So let's try this, right? Let's try with 0, 0. So 0 plus 0 multiplied by 4. Why 4? Because we have 1, 2, 3, 4. Okay, so let's see how that works. Multiplication happens first, right? If you took a math class, multiplication always happens first. So 0 by 4 is 0, plus 0 is 0. So this gives me index 0, and this is index 0, so I can go to index 0. This works. Okay, let's try another element. Let's try 3 and 0. So 3 plus 0 multiplied by 4. What is that? Again, multiplication happens first. 0 multiplied by 4 is 0, plus 3 is 3. So is that the third element? Let's see. 0, 1, 2, 3. Yep, it is the third element, index 3. This works so far. Let's try 2 and 1. Okay, so 2 plus 1 multiplied by 4. What does that give us? Multiplication happens first. 1 by 4 is 4. 4 plus 2 is 6. So let's see. Is that the sixth element? 0, 1, 2, 3, 4, 5, 6. It is the sixth element. 2 and 1 is index number 6. So this works perfectly, right? So that's how we're going to take two numbers, apply this formula, and get a single number, right? And so we're going to apply that in code now. Do you think it would be a good idea to run another advanced series for system and engineering concept, or do you run parallel? Honestly, I don't have the time to do another series. I wish I had the time. I just have way too much on my plates. I have like 4 projects I'm actively working on, plus doing my master's degree, plus teaching part-time, plus doing YouTube. So I genuinely just don't have the time to do another series. Plus, in my experience, if you try to do 2 things at the same time, in terms of, 2 projects at the same time, they're personal projects, not like commitment to other people. You would pick one rather than the other, and the other one would never be finished. So I really just want to finish this series first, and then maybe try jump to in something else. Raw tile number multiplied by y plus x. That also works. I mean, it's the same formula, just in reversed, right? Row tile number multiplied by y plus x. Same exact formula, just in reverse. All right, let's try to apply this formula, right? So I'm going to do int I equal to grid x plus grid y multiplied by the width of my grid. What is the width of my grid? Do I have this data? No, I do not have this data. So this data is in my grid class, right? Is it in my grid class? It should be in my grid class. Cell size, or total cells. Yeah, it's total cells for x and y. So I need to pass in the grid. So let's pass the grid. So does mouse tile have access to the grid? Mouse tile does not have access to the grid. All right, so let's just pass it here. So I'm gonna say grid. Make sure you put a ampersand. I'm referencing. I need to reference this. Make sure this is a const. Why didn't I make this a const? There must be a reason. Am I modifying this anywhere? No, this should have been a const. I don't know why I didn't do it a const. I might have forgotten. I don't know. All right, let's include grid, or this might just create an error. There must be a reason why I didn't do a const. So we'll see. And I also need a grid m underscore grid. So just copy this, put it over here, and so this is going to be m underscore grid comma mouse tile. All right, they're not happy because these are not consts. Okay, seems fine. And then I'm gonna do mouse tile, not mouse tile, sorry. M underscore grid dot. Ooh, none of these variables are consts. Oh, they're private. So I don't want to expose this variable itself, right? I don't want to expose this variable. I don't want to make this public, but I do need it. So what I'm going to do instead, make a function for it, right? So I'm going to make a inline. I don't know if I explained inline. I'll explain it real quick again, just in case I didn't. So inline, what do I want to do? I want total cells. So inline SF vector to I, gonna send it by reference. I'm gonna call this get total cells. It's a function which returns this lovely thing, and this would be a const, and this would be a const. Okay, this seems fine. Is it to I? Yeah, it's to I. Let me explain this line real quick. Because I don't want to expose this function, this variable publicly, right? Because if I expose this variable publicly, someone can just do something like this. Total size x equal to 5, right? They would change this variable, and I don't want anyone to change this variable, right? This is really important. So because I don't want to expose it, because this variable allows to read/write, I'm going to instead create a function that only allows you to read the variable and not write to it. And the way I do that, just make a function that returns the value, and you can never write to this value, right? Now, the way I did this, let me just remove all the confusing things. So this is just a simple function, looks like this, right? And I put it in the header. You can write functions in the header, right? You don't have to just write the declaration. You can full on write it in the header if you want to. Usually for simple functions like these, we write them in the header. If you really wanted to, you can take this entire draw function and put it here, and it would be completely fine, right? It would, no issues whatsoever. This completely works. The reason we don't do it this way is because the more code you add in the header, the more you're including this header everywhere else. And so this code will be included everywhere else, which means your exe will get larger, and it's just compilation time will get larger, and it's not a good time. We talked about this again in a previous lecture, so you can check that out. But for simple functions like these, this is okay, right? So I just have a function called get total cells. It returns a vector to I, and this returns a vector to I. Now, this will make a copy. I don't want it to do a copy, because remember, copying data is expensive. Well, not expensive, but it's not cheap, or it's not free. It costs performance. So there's really no reason to do a copy if you don't have to do a copy. So we send it by a reference. So we send the memory address. The problem if you send the memory address, there's a potential way if you send it by memory address, that memory address can be changed, right? So we send it as a const. So when I send it as a const reference, that means, hey, I'm saying you can get this value, but you can't change it, right? Now, the next thing I'm going to do is add const on the start of the function. The const of the start of the function, what this means, it just says, hey, I promise that any variable inside this function, I'm not going to modify. Meaning, I promise that I don't do this, right? Because this is a variable in the class, and when you put a const at the start of the function, you're promising to not change the variable in the class. We talked about this before, right? So this is what this const is. This const promises that you don't change the variable in the class. This const promises that when you send the reference, you're not gonna change the memory you're not gonna change the value in that memory address. So those are the two consts. Finally, the last thing is the inline. What does inline mean? Inline basically is a hint to the compiler. It's telling the compiler, listen, dude, can you please optimize this code for me if you see fit? Like, if you think this is a good idea, can you optimize it? And the way it's going to optimize it is rather than making a function call, right? So if I call this function, if I go here and I say, where's the thing? Here, m_grid dot get total cells, right? I'm making a function call. I am calling this function from a different class. And just like copying data, function calls or making a function call is not cheap. It costs. It has a cost, right? So what the inline does, it says, hey, compiler, if you could prevent this whole function call altogether, that would be great, right? So the compiler will look at this code and say, okay, is this a good idea? Should I optimize this code or not? the way it would optimize this code is it would literally just not make the function call and return this variable itself. So as if I've done this, right? As if I've accessed the variable directly, right? And so that would mean I'm preventing the cost of calling a function. So if the compiler sees that this is a good idea, it will do it. If it sees that's not a good idea, it will not do it, right? So this is the inline. It might happen, it might not happen, depending on the compiler. Now there's something called force inline. __ force inline basically says, hey compiler, fuck you, you're stupid, I don't care what you think, do this either way, right? So there you go. Programs and compilers don't like each other usually, so we're not gonna force inline. We're just gonna say, hey inline, if you think it's a good idea, do it. And that's the entire function, right? I'm gonna put this all in one line because it's kind of short. It doesn't have to be in 2 lines, so there you go. And so you'll see me using this more often in the future, right? All right, so I'm calling my function, right? I have my grid position plus y multiplied by total grid cells dot x, right? I have my I. So now if I print my I, so we'll just copy this, call this I, and just do I over here and delete this. So now in theory, what's going to happen is that I'm going to see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are not happy. No instance map match. Oh, I need to pass the grid. Let's go, baby. All right, so if I click here, you can see I is 0. Oh, I don't. Let me zoom in for you. Oh, I minus 30. I click outside the screen. So I is 0, I is 1, I is 2, 3, 4, 5, 6, 7, 8, 9, right? If I click here, 10, 11, 12, 13, right? This is every index in the array, which is pretty cool. It's pretty awesome, right? And you can keep going, and the last element is index 49. Now, if you make the mistake and click outside, you'll get 50. And if we actually do index 50, that'll crash our application because there is no index 50 in an array. We say the array is just this big. So if you click outside the array or outside the grid, the application will crash. That's why, and if you click somewhere here, it'll be -1. There is no -1 index ever. That doesn't happen. You start from 0 to the maximum number, right? So if I click, I think I clicked somewhere here and it says -41 again. So what we need to do is clamp. We need to say that you're only allowed to click in this area, not outside this grid. Otherwise, the application will crash. We'll do that bit of optimization. We'll do that bit of code later on, but I just want to get this working. Okay, so this works, which is great. So now I have I. If I go here, now I have I, which is fantastic. Now I can access my array. So I can say map at I equal to, I'm going to generate a new tile. So SF, not a new tile, a new sprite, SF sprite. And that sprite is going to hold a texture. Can I just... Oh, I can assign texture from here. That's great. Okay, so this would be m_tile, mouse tile dot... I want to access its texture. I want to access the mouse tile texture. So I need this texture, right? So I'm going to make an inline function. So inline SF texture ampersand get texture. This will be a const. This is a function. Return, what do I call it? m_tile texture. Okay. And this would be a const. Why are you not happy? Tile texture undefined. How can it be undefined? Or style sheet? I'm stupid. Right. Get tile sheet texture. Right, so this is a function that I can call. Again, I don't want to expose this function immediately, right? Or I don't want to expose this function, so I make a. I don't want to expose this texture, so I make a function that returns a Jesus Christ. Okay. So I'm gonna do here dot get texture, right? And I have essentially. I'm making a new texture. Sorry, I'm making a new sprite with that texture. So here's the problem that I'm thinking in my head. I'm making a new sprite. I'm assigning this texture. Why do I do that? Why am I creating a new sprite? I can just return this sprite, right? But this sprite changes later on. Right, this sprite is changing. So if this sprite changes, all the sprites on the grid will also change. So I'm just gonna make this public for a second, just to show you my train of thought or what I'm thinking right now. So in my head, I'm saying, why? In the head, what I'm saying, why am I making a new tile? I can just return. I can do m underscore tile mouse tile, m underscore mouse tile dot m tile, right? I can just do this, and this would work. If I click here, you can see I'm placing tiles now. This is great, right? I'm placing tiles. I could do that. This is the problem. If the tile on my mouse, right, where my mouse is, if this tile changes, all of the tiles that I placed will also change, because I'm essentially passing them by reference, or I'm gonna pass them by reference. The question is, are they being passed by reference? Yeah, they are, because this is a pointer which points to this. So I'm not sure of that answer, so I'm gonna experiment and make sure that this is what's gonna happen. I'm 99% sure that's what I said is gonna be true, right? So I need a way to change the mouse tile. This is simple enough. What I can do is I need to just as a simple test. I'm gonna say if how do I do this? If SF keyboard A or SF keyboard is pressed, and let's do SF keyboard A. So if I press the A key, then I want to do some changes. I want to set the texture rect to the 12th tile. Right, so if I press space, the 12th tile will be. Okay, well, that did nothing. Oh, it's A. I'm pressing space. What the fuck? Okay, A. There we go. Okay, so here's my theory. Here's my theory. If I click here, 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 and then I press A, all of them will change. Fuck, my theory is completely wrong. Okay. Never mind then. Because this would be doing a copy. This is just copying the data rather than constructing a new one. Yeah, I could just return this. And see, this is why sometimes you have to test things. You might think, hey, this is true, but yeah. So let me explain my train of thought. Why I thought to begin with this was gonna happen, right? What I thought was gonna do, what's gonna happen, is that when I pass this M tile, right? When I pass it in here, it's gonna be passed by reference. Like when I do like this line of code, I thought it's gonna be passed by reference, but it's really not being passed by reference because, well, it's not, right? If I put the ampersand, even if I put the ampersand, that's gonna, because this has to be a pointer. It would have to be a pointer to be passed by reference, and here I'm just doing a copy. So I'm copying the data inside M tile in here, right? I'm not passing by reference, I'm doing a copy, right? In my head, what I thought was going to be is I'm going to pass it by reference and not a copy. And that's why I thought, hey, when the mouse style changes, like so, when I change it to A, all these will change. That's not true because all these are like they're a copy. They're not pointing to the same memory address. Each one has their own unique memory address, right? So cool. So I don't have to. So now this is good. I don't have to construct a new sprite and put the tile position, grid position, all that shit. I can just simply do this. Okay. So cool. So now I'm gonna keep it private. I'm gonna put this back to private. I don't expose this immediately directly. So I'm gonna say this would be sprite mtile. This would be get. What is it called? Get sprite. This is the sprite, or get sprite. We can call it get sprite. This is the sprite that I selected, and I'm passing it by reference. Meaning that this thing is not gonna be passed by reference. Like this thing, when I do here, sf sprite ampersand, I'm not passing the memory address of this tile. All I'm doing is that I'm saying, hey, this function, rather than taking this, copying it in the function returning copy, what's going to happen is that I'm taking this, passing a reference to the function will make a copy, right? So rather than this and just basically says, rather than doing two copies, I'm just going to do a single copy, which should be fine. So get sprite. So let's do another test. Click, 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 and press A. Click, 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 right? I'm placing tiles, guys. Works. Look at that, beautiful. Absolutely beautiful. Obviously, every time I click outside the application crashes. The reason the application crashes is because I am trying to access the array at a certain location in memory, and that location doesn't exist. Remember the -1, -40 that was happening. So yeah. Okay, so really I don't need this, and I don't need this, and I don't need any of that. No, I need I don't need the tile position. So I'm never gonna use the tile position, but I'm gonna keep it here for now. Whatever, doesn't matter. Okay, cool. I can place tiles. That's huge. I have a map editor, guys. Or we have a map editor. That's awesome. Click, 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 click. Press A, change, click, 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 click. Right? That's cool. Okay. So real quick overview on what we've done here. Kind of explain what's going on. In the update function for the map, essentially I have two variables that will hold the memory addresses for tile position and the grid position, and I'm passing the mouse position here. This function, all this does is that when I click the mouse position, it calculates the tile position and the grid position. Actually, that math is being calculated here in update, and it's just being passed over here, right? And so in here, all I'm doing is converting those grid positions, the 0, 0, 0, 1, 1, 2, 2, 3, and so on, the position on the grid to a single integer. That integer is being passed as an index number for my map sprites. I'm rendering all my map sprites, and I'm assigning the current map sprite. So essentially, if I click, when the map style changes and I place it on the screen, it will be placed on the screen, like you saw. Okay, hope that made sense. Cool. What's next? I'm passing this as an inline. I'm preventing a copy from mtile to the function. The function then returns a copy to here. So this is going to return a copy of it. Just the ampersand here will prevent the copy from the variable to the function. That's kind of important to remember. I'm thinking. I am thinking. Huh. Hold on a second. I have a question. I have a question. Have you tried SFML with Rust? No, not really. I've never used Rust before. So I don't know Rust at all. So I'm using SFML with C++. I have a question. I'm doubting my explanation here for a second. What I'm saying is this is gonna return this function getSprite is gonna return the memory address of m_tile, which means it's going to return a reference to it and saved in this pointer. This pointer holds all the memory addresses. This makes no sense to me. Hold on. I'm a little confused. I would like to do some experimentation. Hold on 1 second. What I want to do is I want to put a breakpoint here. And I want to put a breakpoint here. Okay. If I click anywhere on the thing, go in here. The memory address of m_tile. What is the memory address of m_tile? So you have a watch window. If you don't have a watch window, these are really useful for debugging. Or you can just see the locals window. The local window is available in debug window locals, right? You can get that. So I'm just looking here at the memory address of m_tile. Or I'd like to find the memory address of m_tile. What is the memory address of this? Let me just grab a watch window. So debug window watch 1. And I'm gonna say I want the memory address of m_tile. The memory address of m_tile is ccccc 4 f4, right? This is the memory address of it. So when I return it in here, in theory, this should hold this memory address. So in here, what I want to do, I'm gonna say gotta copy this. I want at index 0 the memory address of it at index 0. It is a different memory address. I thought these two memory addresses would match. But why is it a different memory address? Why is it not the same? Why is it not the same memory address? Because this is returning an ampersand. This is returning a reference, a memory address of this, which should be stored in this array of. Is my original explanation correct? Is this a copy? Should be a copy, right? I think this had to be pointer to be not a copy. Okay, hold on. What if I do this? What if I make a new pointer, sf sprite pointer called p, and I do this? I return the memory address, and I can't do that because this returns a reference and it's const. Yeah, can I make const pointer? No. Memory address. Okay, so this works. So what is the, if I click here, memory address of m_tile is ladies and gentlemen, Memory address of P is FF088. Where's the memory address of tile? Is 98. This is 88. What if I do dereference P? How are these not the same memory addresses? Pointer 88. This pointer has a memory address of 88. M underscore tile had the memory address of 98. How the fuck are they not the same memory address? I'm returning by reference. Okay. The plot thickens. Hold on. What if I make this public? And instead of doing get mouse tile, I just do M underscore tile. What is M underscore tile? It is, well, it's undefined. I have to type this. This is for, now it's the same memory address. Now it is the same memory address. Okay. So are you telling me? I must be missing something. It's called this P1. Are you telling me if I remove the const, first say remove the const here, and I remove the const here, I don't need these consts anymore. Const sprite, what is it const? Who said it's const? Oh, okay. I need to make it not const, hold on. So, this thing. I'm just experimenting, sorry guys. I need to figure out this solution because this makes no sense in my head. I need to make sure I'm explaining things correctly to you also. Fuck off. Just remember address. Thank you. Okay. Going here, right? The memory address of M underscore tile is 938. The memory address of P1 is 348. It's the same as, so P and P1, they hold the same memory addresses, same as M underscore tile. So all of these guys, they hold the same memory address. This holds the same memory address. So P holds the same memory address as M underscore tile as P1. All of these hold the same memory address. Okay. That's good. That's what I expected. That's what I expected. That they all hold the same memory addresses, because this function is returning the memory address. But it seems that this one does not hold the same memory address at all. Question is why? So element one would hold different memory address. Yes, which it does. Because I'm making a copy. Because I'm fucking making a copy. I'm a fucking idiot. It's the same thing as doing this. SF sprite s equal to this. I'm making a copy. This is making a copy because this is not a pointer. I'm copying, even though I'm returning by reference. This is the same fucking thing that I did last time where I didn't put ampersand here, right? Okay, so my explanation was not completely correct. So let me explain what's going on. It's for everyone's benefit. Okay, remember when I said ampersand here? Well, my explanation was correct but not clear, or not clear and super clear in my head, but here's essentially it. I'm returning the memory address of mtile, right? This is essentially what I'm doing. I'm returning the memory address of this variable. This function returns the memory address of this variable, right? This is what's happening right now, right? So if I make it const, then I'm returning the memory address of this variable, and I'm promising that I cannot change any data in this tile, because think about it. If you return a memory address of something, so this function, if let's say it's not const, right? And I'm returning the memory address of m_tile. That means I can do things like this. I can say m getSprite dot set color, and I can change the color, right? Because I'm modifying, essentially, getTile is the same thing as saying, hey, I have full access to this variable because I have full access to its memory address, right? So to prevent doing things like this, to prevent doing set color or changing any of its properties, because again, getSprite is essentially returning this variable. It is returning the memory address of this variable. So to prevent me from doing set color, set position, or modifying any of its things, I say it's a const. So when I say it's a const, then I can't simply just do set dot rate. I don't even have the options, none of the options here, but if I do set color, right, it's going to be mad at me. SF color red, right? It's going to be mad at me. It says, hey, you cannot do this. You promised that. Where's your problem? Not get set, right? It's going to be mad at me because it says, hey, this is a const. You cannot change this. You promised you would not change this. You promised when you created this function, which is called getSprite, you promised it's a const, which means you will not change this variable properties. That's why this const exists. So again, however, if you remove the ampersand, right, now this is a copy. I'm making copy. So it doesn't matter. I'm just doing a copy. It doesn't fucking matter what you do. But here I'm returning the memory address of this, which means I can affect this variable. I can change its properties, which you don't want to do. That's why you return a const reference, right? Cool, that's super clear. Great. So what is happening here on this line, right? So what I was doing and what I was experimenting with is that I was checking the memory address. When I return m_tile, when I return the memory address of m_tile and I save it in a pointer called p, will the memory address be the same as these two? Yes, they are the same because getSprite returns the memory address because I have an and here, right? And if I put an and here, this also returns the memory address because, well, it's the fucking memory address, right? Cool, so both of these have the same memory address. Now, if I do it this way, however, these are pointers. This is a pointer, this is a pointer. Both of these variables hold a memory address. This doesn't hold a memory address. This makes a copy, right? Even though getSprite, even though this function returns the memory address of mtile, I am not storing a memory address inside S. I'm storing a copy. I'm storing the properties of this. I'm copying the properties of m_tile inside S. Because getSprite returns m_tile, getSprite returns m_tile, and it's saved in a new variable called S. So I'm copying whatever data in here into a new variable S. Here I'm not doing a copy. I'm just returning the variable itself. I'm returning the memory address inside P, and because P holds a memory address because it's a pointer. So what I was wondering is, since that getSprite returns a memory address right here, right? getSprite returns the memory address of m_tile. Because we are doing that, why the fuck doesn't the array change? As in, let me comment out these lines, as in y, oh y, when I do this, when I place a tile, and then I press A and change this tile, why don't these change on the screen? Well, they don't change on the screen because even though I am returning the memory address, of m_tile, and I'm saving it in this array, I am doing a copy because this array doesn't save memory addresses, it saves the copies, right? It's saving a copy, that's all. If I wanted to save a memory address, I think this had to be a pointer. So I have to dereference this. And here I'd have to, here I would remove the const. I'd have to remove the const here, right? And I would have to put an ampersand here. So now this is a you're not happy. This would be a pointer now. This is a pointer, right? So this is an array of pointers. They're no longer an array of sprites. They're an array of pointer sprites. And this is gonna crash because it's not, yeah, of course it's not gonna work because so what I have to do, if equal null putter, it does not equal null putter, then draw this, right? And in here I have to loop through all of these and say that all of these are equal to null pointer. Okay, so this should be fine. Hopefully it shouldn't crash. Right, so if I now click, well, nothing happens, and I press A, nothing's happening. What the fuck's nothing happening? I'm returning the memory address. They're all nulls, sir. Fuck, I don't know how to do this. Tell you the truth. I think pointer would work, but I don't quite know how this would work. It has to be dereferenced. Yeah, I think this would work. Hold on. Oh, crashed. That's lovely. This does return the memory address, which is, this is a pointer. I mean, what? No, this is returns a memory address. This is a pointer to hold the memory address. If I dereference this, I need to make when I'm returning him, should work. What? Oh, I've gone down the rabbit hole of shit that I don't quite understand because I don't use C++ every day. Think about this logically, dude. You're making an array that holds pointers. You're initializing the array. You're accessing every element in the array. This would require the sprite. This is just the pointer. So the pointer at element I would need the memory address. Let's just do m_tile. Need the memory address of this, right? Click. Why is nothing showing up? I think they're all still null pointers. No, it's not a null pointer. It should draw it. So element 0 is not all on pointer, and then element 1 is drawing all of them. At least in theory, should be drawing all of them. Shouldn't draw all of them though. So 0, only 0 should be drawn, right? And then element 1 is not a null pointer. Right. Yeah. If I remove the statement, these will all crash. Okay, what if I just... I'm experimenting, guys. Give me a second, sorry. I know this is supposed to be educational, but I'm experimenting with new things that I've never done before. So one moment, please. It still crashes because that index 1 is null, that's what is supposed to happen. What the fuck am I doing? Okay, so if I put the if statement back, hold on. If I put the if statement back, that should be fixed. I just do this, so element 0 would be drawn. It should be drawn. Why is it not drawn? Why is element 0 not drawn? Yeah, it should be drawn 0. And then 1 should not be drawn. 1 is also drawn. How is 1 drawn? What is going on? I'm confused. This is an array. This is a variable of 2 pointers. The first pointer points to the memory address of the array. The second pointer is for every element in the array. At least that's where I think it should be. So I'm looping through all the memory addresses. And for every element, because it's a pointer, I'm just saying it's null pater. And then here I'm initializing a new array of pointers. Right? This would not be correct. Yeah, because mstr doesn't point to anything. So this array is being whatever. This array is the element which goes to every pointer. What if I do 0x001? Well, this should be hexadecimal, should be a pointer. Next play. Okay, whatever, fuck you. Honestly, I'm lost. I don't know. I went through a rabbit hole that I shouldn't have went to. Where's the memory address of this? Or this is where the array starts. Should have. Okay. You know what? Google time. Google time. Okay. What am I Googling? Create an array of pointers. C++. It should be pointer. Like, it should be pointer. Yeah, shut the fuck up. So it's a pointer that holds the array. Array of pointers, okay. So I have an array. That's great. I have a pointer array, right? And that's what I'm doing. No, I have a pointer to an array. But the reason I need a pointer to array is because the first pointer points to the array and every other pointer points to... Okay, you know what? Shut the fuck up. We'll just do this as max size, which is 50. Well, I already have the size here. Why? Because I'm hardcoding it. I don't want to hardcode it, just whatever. So if I just do this, so this is now an array of pointers. Yeah, shut the fuck up. Nope, same issue. This has something to do with C++. Sorry, SFML. Also, what I really don't understand is how is it rendering the sprites when these should be null? They are all null except for the first one. Why is because 0 is over here. Okay. And see now the second one is fine. How's it going to the second one? If that is not null, then draw it. But it is null, so how's it drawing it? If I go here at index 1, that should be null. If I go at index 0, it should be whatever, right? So if I put equal null PTR, that is true. So how is it stepping? How is it going? How is it rendering this? If it's equal to null, see, this is index 1. I hover over I. It would let me fucking hover over I. Yeah, I is 1. So how is it going to draw? Let's put some scopes. So I'm saying for every iteration in the loop, if this is not null, then go in here. And this should only work for the first index, which is index 0. So index 0 is fine. It goes in, right? And then whatever. I don't care, right? And then when we're done with 0, it increments to I is 1. I at 1 is null. So it does skip it. What? Okay. You'll see it was an asshole. It was telling me that it was going in, even though it wasn't going. What? Which one? 0, yeah. Okay. But now it's not rendering. It's not rendering it. It should be rendering it. Why is it not rendering it? I'm dereferencing it. I can't draw this. I need to dereference it, then say draw index 0. I'm assigning index 0 to the memory address of m_tile. Fucking hell. I'm so fucking stupid. I know why this is happening. Oh my god, I am such a fucking dumbass, dude. This. The reason you guys can't see. Okay, so look, here's what I'm saying. I'm saying this is an... Shut the fuck up. This is an array of pointers, right? Forget the double pointers. I was doing it right, but I was doing it right before, right? Everything I had before was right? I have an array. This is an array of pointers. Each element in the array is a memory address. If you remove the pointer, then every element in the array is a sprite. Put the pointer, every element in the array is a pointer to a sprite. Okay, so this is my array. This should be a memory address, right? If this was a pointer, it's an array of memory addresses for sprites. If I remove the star here, this is just SF sprites. Every element is a sprite, right? So just keep that clear, okay? Cool. I have an array of pointers sprite, which means every element holds a memory address of a sprite. Every element holds a memory address. It doesn't hold a sprite, it holds a memory address. Okay, cool, we got that covered. What I'm doing here, I'm looping through every element in the array, and I'm saying that every element in the array is a null pointer, right? Because remember, this is array that hold memory addresses. So for every element, I'm just saying this memory address is null or 0. In here, what I'm doing is I'm saying, hey, give me the memory address of the m_tile and make it equal to the element 0. So now element 0 in the array holds the memory address of m_tile. And I'm just rendering, I'm dereferencing the array, and I'm dereferencing the first element, and I'm rendering it. Now the question that I was asking myself, why the fuck is it not showing? Because this is supposed to be a tile over here, right? There's supposed to be a tile over here, but I'm not seeing it. Why am I not seeing it? Well, you fucking idiot. I'm talking to myself right now. You dumbass. You are saying that element 0 holds the memory address of tile. The tile is moving on the screen because of my mouse. And so when I draw the first element, I am drawing the tile. So I'm drawing the tile twice. So the reason I'm not seeing it over here is because it's behind my mouse, because my mouse is moving. So there are 2 fucking tiles where my mouse is right now. That's why I can't see it. Because I'm sending the same memory. I'm literally sending the memory address from _tile. Just so fucking stupid. I'm just sometimes my stupidity is just beyond belief. That's the reason. So what I had before, what I had 2 pointers, yeah, that is correct. The first pointer points to the array, the second pointer is for each element in the array. So if I have pointer, the first pointer points to the memory address of the array. So this entire array has a memory address. The second pointer points to every element, right? So the second pointer is that every element in there holds a memory address. Element 0 holds a memory address. Element 1 holds a memory address. Element 3, element 2 holds a memory address. So this pointer points to the memory address of the array, the entire array. This pointer is the pointer for every single element in the array. So it's saying you hold in here, the first element is a pointer. This is a pointer. This is a pointer, right? So just what I had was correct. And when you do it this way, this is also an array. When you do it this way, this is also an array of pointers because I'm specifying the array over here. I'm creating the array of pointers over here. When I did double pointers is I'm saying, hey, I will create the array of pointers later on in my program. So I created here. So I'm creating the array later on in the program. So what I had was just correct. I'm just fucking stupid. That's essentially what's happening here. So going back to what I had, and really the question of the question of, I wanted to prove to you that always put scopes because apparently Microsoft Visual Studio is fucking stupid. But essentially what I wanted to try to prove to you that what I wanted to prove to you is that this is returning the memory address. And so when I put the memory address over here, I'm doing a copy, right? This is just a pointer to an array, right? This is the array. So when I put one pointer, this is a pointer to array. If I put two pointers, this is a pointer to array that holds pointers, right? Okay, so what I wanted to prove to you is that if I put a tile, if I have double pointers, and I put a tile over here, right? And then I press A, all of them should change. I wanted to show you that, but I couldn't show you that because all of these tiles are fucking behind. Their positions is being changed. It's behind my mouse. And so that's why I couldn't see them. The point is really, the gist is, right? I'm sure you're confused as fuck, and I'm sure you've literally closed this video an hour ago saying this guy's an idiot. What the fuck is he talking about? I'm done. Have pathetic. Hey man, okay. Okay, don't be mean. This is Rainer, everyone. Welcome, Rainer. He's an asshole. So he's my friend. Don't worry. I wouldn't call a viewer an asshole. Well, maybe I would at some point, but no, he's my friend, so don't worry. Anyways, this is a pointer that points to an array. Every element in the array, they're just regular elements, right? And I'm showing all of them. So this function getSprite returns the memory address of mtile, right? So we're not doing a copy here, but we're doing the copy over here. So even though I'm returning the memory address, this is an array. It holds an array of sprites, not pointers. So I'm essentially copying stuff in here, right? So I am doing one copy. However, if I remove this, I'm gonna do two copies. So my explanation was correct. I just wasn't too convinced, and I just wanted to make sure I was right. But you know, I should follow my instincts and say, you know, I am right. I'm always right. That's the thing. I'm kidding. I'm not always right. But anyways, solved. Crisis averted. I'm stupid, which is fine. So bunch of things, right? Press A. I can place a bunch of things, which is cool. Okay. So one last time, real quick. I have an array of sprites. I have a pointer that points to the array because I want to create the array later on in my program. Because at some point, right? Because at some point in my editor, I'm gonna add a feature that changes the grid size or let the user pick the grid size. It's not always fixed, so I have to create the array later on in the application. So that's why I can just do it here. So that's why I said it's a pointer. So to delay the initialization of the array. So this is just an array. This is a pointer that points to an array. Every element in the array is just a regular sprite. When I click here, I'm returning the memory address of sprite, but I'm copying the data inside the array or inside one of the elements in the array, right? So I'm doing a single copy, which is good. That's what I want. I don't want to return the memory address of m_tile, because if I do that, and it's just, then all the tiles are just behind my mouse because I'm moving the tile, and because all the pointers point to this tile, right? So imagine this. This is my grid, right? This is the first element in my grid, second element in my grid, third, fourth, fifth, and my mouse is over here, right? If I make all of these pointers, if I make all these lovely things pointers, and I return the memory address, then this points here, 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 this points here. Meaning that if this square moved to somewhere else, if this square moved over here, then now all of these are pointing to the same square, right? And now this is gone, right? There's no square here. Now all of them are pointing over here. right? Which means that the actual tile, all the tiles are just being rendered behind each other. Like all of these elements in my array are pointing to this thing. But this is not what I'm doing. I'm not saying that this is a pointer. I'm not saying that this is a pointer, right? These are just memory. This is just elements in the array, right? And so when I do this, I am copying the data and putting it here, copying the data, putting it here, copying the data, putting it here, and so on and so forth. Meaning that if this square moves somewhere else, it doesn't matter because there's already a square over here. There's a square over here, right? These are their own independent guys, right? That's what I'm doing in my code right now. I hope this made sense. I really do, and I'm really sorry for the detour, but I needed to kind of do this. And again, this is not just a stream for teaching stuff. Also, I'm rusty with C++, so just whatever. Hope that made sense. Hope we're all good on the same page. We were on the same page an hour ago, I think. But there you go. Okay, so I can place tiles, right? Which is good. Then I can place some more tiles. Okay, that's great. The next thing I want to do is do some GUI. How long is the stream? Whoops, sorry, you're gonna see that on stream, right? This is an hour and 30 minutes. Okay, what I'm gonna do, stop the stream, start a new one, right? Let me just save everything. So I'm gonna say let me make sure my code is clean. These are private. This is a pointer. Like this. Okay. So all looks good. This is inline with reference const. This is private. Okay. So all of this looks good. Let me commit my code. I'll start another stream so I don't make this too long. I need to move this read right. Where is this? Grid.h. Yeah, get the fuck out. Go back here. Okay, I did this function. Yep, that's all good. It's all fine, all fine. Okay, so what I'm gonna do here, I'm gonna say you can now place tiles in the grid. Cool. Push that. And let me restart the stream, start a new one, just because I don't want to make this too long. An hour and a half is enough. And then we'll start with the GUI. All right. Push, 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 push. All right, I'll start a new stream. Thank you guys. Hope you enjoyed the fucking disaster that the stream was, and it's gonna happen a lot moving forward. So yeah, that's the problem. But I hope you guys enjoyed this. Please subscribe. Half of you guys are watching or not subscribed. Do subscribe. It would help me a ton. Like the video. It would help me a ton. Hope you enjoyed the content. And yeah, I'm gonna stop the stream, restart it, and start the GUI stuff. So I'll see you guys in literally 2 seconds. Bye bye.